Good evening, Priyansh. Good evening, Vaibhav. We are going to start new chapter today. Structure of the atom. A very, very important and very interesting topic. And this chapter is going to clear your basic of chemistry, right? Only two have joined. Okay, so let's start the structure of the atom, right? This chapter is very, very, very important because initially when Dalton has given its theory, Dalton has given one postulate that atoms are indivisible. We have studied about matter. Matter is made up of tiny particles known as atoms. And as per Dalton, like in 1808, Dalton had suggested that atom is the smallest indivisible particle of matter. And then he further elaborated this idea by putting forward a theory known as Dalton atomic theory, and because of that theory he is known to us, and most of the portion of that atomic theory was accepted by most of the scientists, but there were few things which were not accepted. Good evening, Devansh. So this theory was not was able to explain the law of chemical combination, like law of conservation of mass, law of constant proportion, right? And then the concept of relative atomic masses was also developed because of his Dalton atomic theory. However, Dalton concept of atom could not explain why do atom of different element differ from each other in their masses and the property, because as per Dalton atomic theory, atoms of the different element will be different in all aspects, masses or chemical property. But we know that some atoms, right, some of the different atoms, they also have same mass number, like for example isobars. Isobars are the atoms of the different element, and they have different atomic number but same mass number. So they have different atomic number but same mass number. It means they are having something similar. But as per Dalton atomic theory, it was told by Dalton that atoms of the different element will be different in all aspects, right? So in that case we can prove him wrong. Dalton was wrong because Dalton atomic theory could not explain that why do atoms of different elements differ from each other in masses and properties. And the second thing, why do atoms combine to form molecules, right? He could not explain this, because we know that when atoms have unstable electronic configuration, they do combine with other atoms in order to become stable, and they want to achieve a electronic configuration just like noble gases. Like noble gases are having stable electronic configuration, right? And then the existence of the charged particle in matter, he has never explained that there is something inside the atom which is a charged particle, right? Good evening, Abhishek. Good evening, Kovid. Good evening, Divyansh. Okay, so he could not explain, right? So to look for an answer the above questions, like why do atom of the different element differ from each other in the masses, or why do atom combine to form molecule, right? So further studies were carried out by the various scientists. Then they wanted to prove that whether atom is really indivisible or something is inside, because they do carry some charged particles. So what they have done very simple experiment, right? If we comb dry air and then bring the comb near the small pieces of paper, comb is found to be attract towards the pieces of paper. You can do the same experiment at home. You rub the comb, right? You rub the comb and then try to bring the small piece of paper near to the comb. Then you will see that the small pieces of paper will attract toward the comb. It means there is something which is attracting the pieces of paper in the comb, right? And if we rub a glass rod, there is one more example. This is also a very simple experiment. And if we rub a glass rod with the silk cloth and then bring the glass rod near an inflated balloon, it is attracted toward the glass rod. Can you see that? So if we rub a glass rod with the silk cloth, you continuously rub, right? Obviously it is going to acquire some charge, and then bring the glass rod near an inflated balloon. So balloon will attract towards the glass rod. It will get stick, right? So as electrically charged particle can attract uncharged particle by inducing opposite charges in them, right? It means uncharged particle means by inducing opposite charges in them. This shows that in the first case where we have used comb, right? Comb acquires an electric charge, right? In the second case, what we have done? We have rubbed the glass rod with the silk cloth, right? In the second case, glass rod acquire electric charge. Then the question arises, where does this electrical charge come from, right? We should ask this question, but Dalton was also saying there is no charge at all, there is no subatomic particle inside the atom. But if we rub the comb with the dry air and then we bring the piece of paper, they are going to attract. If we rub a glass rod with a silk cloth, they are going to acquire some charge. So the question arises, from where does this electrical charge come from? Now, as comb, glass rod, etc. constitute matter, and matter is made up of atoms, and there must be some charge particle present in the matter, right? Otherwise, so how they are going to attract the other particle? Yes or no? So Priyansh has written electrostatic force. Electrostatic force will be between cation and anion, right? So in that case, we should try to find out the answer. As the Dalton said, it cannot be subdivided. It is indivisible particle. But when we have done these two simple experiments, we found that the particles are attracting, right? It means where does this charge comes from, right? So then further experiments were performed in order to find out whether atom is really indivisible or it is divisible, right? So if we see that like in case of comb, glass rod, constitute matter, we have discussed that matter is made up of atom. There must be some charge particle present in the matter, right? Hence in the atoms, in other words, we can say atom is divisible, right? So further experiments were performed during this year, right? For example, between 1895 to 1905, where they have showed that atom is not the smallest particle, right? They have proved Dalton wrong, that atom is not the smallest particle, but it is made up of still smaller particle called subatomic particles, right? It is still made up of more smaller particle called subatomic particle, and three subatomic particles were electrons, protons and neutrons. In other words, we can say atom has internal structure of its own. We can't say it cannot be further divided, right? Good evening, Akhil Tripathi, right? So we can say, so if we want to study this chapter, so what should be aim of this chapter? To right, our aim should to discuss how these subatomic particles, that is electron, proton and neutrons, were discovered and how they are arranged within the atom. Then we should know how they are arranged, whether they are outside or whether they are concentrated at a one place, right? So our objective of this chapter to find out how these subatomic particles, that is electron, proton, neutron, were discovered and how they are arranged within the atom. So that is known as study, right? To study the model of atom. What we need to study here? We are going to study the model of atom, right? So first we are going to start the discovery of electron, the study of cathode rays, right? So we are going to study of cathode rays. So we can easily find out how electrons were discovered. So the very important portion of this chapter is cathode rays, right? So if you know the how the electrons were discovered, how protons were discovered. You can automatically come to know about the discovery of neutrons, and the neutrons were discovered by James Chadwick after the discovery of this, right? So we can see how electrons were discovered. So we will try to understand with the help of discharge tube experiment, because the existence of electron in atom was shown by J.J. Thomson. So who has explained this, who has given us the knowledge about the existing of electron, right? So that was given by J.J. Thomson, right? And in which year he has explained us? In 1997. Understood, everyone? Understood? So, the existence of electron in atom was first shown by J.J. Thomson in 1897 on the basis of detailed study of cathode rays. The discovery of cathode rays was made on the basis of discharge tube experiment using air or some gas. You can see I have drawn here for you the discharge tube. You can see this is what actually. Discharge tube is always made up of what? It is a long glass tube, right? Closed at the both end. You can see both the ends are closed, right? And a discharge tube is a long glass, and it is made up of very hard glass. It is not as made up of simple glass. A discharge tube is a long glass made up of hard glass, right? And two metal plates are kept, right? This is one metal plate, this is another metal plate, this is A and B. We can see two metal plates, right? So two metal plates were kept inside, or you can say the two circular metal plates, that is A and B, are sealed at the two ends of the test tube. One is in this end and another is in this end. We can see in the both ends, we can see two circular plates are sealed at the two ends of the test tube. And what is the other name of these plates? Electrodes. So we can see one is cathode, this is also electrode, and you can see negative charge is there because we will see it is attached to the negative terminal of the battery. If it is attached to the negative terminal of battery, so it means which electrode is this? This is cathode, right? Cathode is a negative electrode, right? Now we can see the another one is connected to the positive terminal of the battery, so it is anode, right? So what is the name of this B part? The B metallic plate, that is anode. Anode is a positive, this is positive electrode. Why this is positive electrode? Because it is connected to the positive terminal of the battery, right? Understood, class? So this is positive, this is connected to the positive terminal of the battery, so this is positive electrode. Understood? Okay, and positive electrode is always known as anode. It means plus. Why? Because it is connected to the positive terminal, and this is negative electrode. So we have understood a discharge tube is what? It is a long glass. It is made up of hard glass and two circular metal plates, that is A and B. A and B are there. They are sealed at the two ends. We can see at one is this corner. This is, for example, this is A and this is B. Another is B on the other corner, right? And these are known as electrode. One is positive electrode, another is negative electrode, and negative electrode is known as cathode and positive electrode is known as anode. Till here understood? Okay. So now you can see a side tube is also connected to that. We can see this is a side tube. Why this side tube is there? A side tube is also fused in to the test tube, which can be connected to the vacuum pump, so that we can increase or decrease, we can increase and decrease the atmospheric pressure inside this. Understood? So that we can increase or decrease the pressure inside the glass tube. So we can adjust. If we want to increase the pressure inside, so we can increase it. If we want to decrease the pressure, we can decrease it. So one side tube, and this is S. So what is the name of this tube? S tube. It is fused to this glass tube and which is connected to the vacuum pump Why it is connected to the vacuum pump? So that we can increase or decrease the pressure inside that. Understood? Okay, so till here we have understood. So we can and then two plates A and B are connected to a source of electrical. We can see here. I will shift little bit, then you can see easily. So we can see that this is connected to a battery source, the electrical power source, such as induction coil, and it has a capacity of how much volt? Very high volt. It has a which can supply a very high voltage, that is more than 10,000 volt. You can see here 10,000 volt is written, right? So we can see here 10,000 volt. Understood, class? So right now we are understanding the structure of the discharge tube, and if you understand the structure of the discharge tube, you can easily understand the discharge tube experiment which was conducted by J. Thomson in 1897, right? So we have understood that he has used one glass tube which is made up of very hard glass, because we wanted to apply a very high voltage current. So it should be very hard, otherwise it will break because of the high pressure, or maybe because of the high voltage. So and then we have we have kept two metallic plate, that is A and B, right? And then there was one side tube was also there to adjust the pressure inside, so that we can increase or reduce the pressure, right? So if you want to suck up, what is the function of the vacuum pump? To suck up, so to suck out the air or gas present inside, right? Or whatever gas or air is present, to suck out, right? So then we have I have also told you that these electrodes are connected to a very high voltage electrical supply, and that is what actually 10,000 volt. Understood? Okay, now the plate A, which is connected to negative terminal, we know it is cathode, and the plate B, which is connected to the positive terminal, is known as anode. Now, how we can produce what we are going to study in this discharge tube experiment? How we are going to produce cathode rays, right? Then we can understand the definition of electron. We can understand how cathode rays are going to carry electron. Okay, so what happens? He could not achieve, he could not done this successfully. He has tried various method, right? And then but he was using, every time one thing was common, that he was using discharge tube. So there was some observation. Whatever he has tried, I will explain you, then you will better understand. Then on applying high voltage, you know that the voltage is 10,000 volts, right? What was the voltage? 10,000 volts, right? So on applying high voltage between the electrode, that is cathode and anode, so on applying high voltage between the electrodes, the result observed at a different pressure, because I told you there was one side tube also to adjust the pressure. We have a vacuum pump here, right? So what he did, then on applying high voltage, that is 10,000 volt between the electrode, the result observed at a different pressure of the air. You can take air also inside that, you can take gas also, right? So there are some observation which I am going to explain. The first observation: no flow of current at ordinary pressure, because we know that at normal pressure, air or any gas is a poor conductor of electricity. So when the pressure was taken, normal pressure is 1 atm, 1 atmospheric, right? Or 760 mm of mercury. So when the air inside the discharge tube is taken at a normal atmospheric pressure and the voltage was applied, that is 10,000 volt, nothing was happened inside the test tube, nothing was observed. So no current flows through the air between the electrode or any gas through the if the gas was taken, so no current flows through the air or a gas between the electrode. This is because air or any gas at normal pressure is a poor conductor of electricity. Understood, class? It is a poor conductor of electricity, right? Now Then what happens when why the glow was produced? So glow in the entire tube at 1 pressure. If the air inside the tube is sucked out by connecting the side tube, as I told you, this is the side tube. So okay, so if the air was if if the air inside the tube is sucked out by connecting the side tube S to the vacuum pump, if you take out all the air through this vacuum pump, what is going to happen? Okay, and so that the pressure falls to 1 of mercury. Initially 760 of mercury was there, right? So if the air is sucked out with the help of this vacuum pump, and to bring 1 of mercury pressure inside the tube, now voltage will be the same, that is 10,000 volt will be applied. Now what is the pressure? What is the pressure? Initially when they have taken normal pressure and 10,000 volt was applied, so no current flows through the air between the electrode, because any gas or air, they are poor conductor of electricity at a normal pressure. So nothing was happened in the first case. Then he had tried that he has sucked out the air from the discharge tube, and they bring the pressure up to 1 of pressure, 1 of pressure, and the same amount of voltage was applied, that is 10,000. Then the current begins to flow. Then what happens? The current begins to flow between the electrode through the air inside. Hence the entire discharge tube begins to glow uniformly with magenta red color. What was the color initially was observed? Magenta red color. You can see the magenta red color is there in the induction coil, right? So when how much pressure was applied? 1 of mercury. And how much voltage was applied? 10,000 volt, right? So what was the observation? Abhishek, what was the observation? What was the observation? Then he observed that the current begins to flow between the electrodes through the air inside. Hence the entire discharge tube begins to glow uniformly with magenta red color. The color emitted depends upon the nature of the gas, which gas we have taken. If neon gas you will take, the the light emitted will be reddish orange, and sometimes you'll observe the blue color. It depends which gas is taken inside the test tube, discharge tube. Okay, so that time what he observed, when the air was taken, magenta red color can be seen in the entire, means everything was filled here, right? Then glow intercepted by dark bands at the lower pressure. When he further decrease, or you can say reduce the pressure up to 0.00, you can see a 0.001. When he further decrease the pressure with the help of the side tube S, so that with the help of vacuum pump it can suck out the more air or a gas. So how much pressure was this time was noted? 0.001 pressure, right? So this time how much pressure? It means he has further lowered the pressure, right? If the air inside the tube is sucked out further, so that the pressure inside the tube further falls down, and high voltage applied as before, like 10,000 volt, right? The glow is intercepted by the dark bands at the right angle. You can see there is an intercepted. This glow is intercepted, right? And the glow is intercepted by the dark bands at a right angle to the axis to the tube, right? Now when you production of the cathode ray, at what pressure you can see this, it means that the production of the cathode rays will take place at 0.001 of pressure, right? So when the pressure of air of the gas inside tube falls to 0.00 and discharge tube and completely inside the tube completely disappear, and there is no light emitted by the air, right? The tube appears completely dark when you further decrease the pressure. And however, the glass wall of the tube exactly opposite to the cathode glows with a greenish yellow light called fluorescence. Greenish, the glass wall of the tube exactly opposite to the cathode, yani ki you can see here the greenish yellow color. So greenish yellow color glow can be seen at what pressure? I have told you 0.001 mm of pressure, right? So in that case, so what was this actually fluorescence? There were some invisible rays coming from the cathode when travel in the straight line, right, and strike the glass wall opposite to the cathode. It means this thing proves that they were traveling from which side to which side, from cathode to anode. That's why the glow was seen at the back of anode. Yes or no? Why the glow was produced at the back of the anode? This proves that these rays were traveling from cathode towards anode. These rays were traveling from cathode towards anode. That's why the greenish yellow glow was produced between the, or you can say the back of the anode rays. Anode, that is a positive electrode. Understood? Understood? So when they strike the it means they were carrying some rays, right, and these rays were originating from cathode. It seems to be they are originating from cathode. That's why he has given them name, that is cathode rays, right, since these rays were originating from cathode, right. Understood? And that's why he has given them name cathode rays. Understood? So you can see that what happens at normal pressure, no current flow was there. What happened at 1 mm? So we have seen the magenta red color. When then glow intercepted by the dark band, when you further little bit decrease the pressure, and when the pressure was about to reach to 0.001 mm of pressure, right, so the gas inside the test tube falls to what pressure? 0.001 mm, and the discharge tube completely disappear. Discharge tube, the tube completely disappeared. There is no light emitted by the air. The tube appears completely dark, and however the glass wall of the tube exactly opposite to the cathode, that is the anode, we can see the greenish yellow glow, right. So they were hitting at the back, they were striking at the glass wall of the opposite electrode, that is anode, right. And since these rays are coming from the cathode rays, that's why the name was given cathode rays. I hope everybody must have understood. Now if you have understood, so we can study the properties of, we can study, we have understood how the cathode rays were produced inside the discharge tube, and then we are going to study properties of cathode rays. Okay, understood or not understood? First let me know from you. If you have understood, please write ma'am understood, and then we'll go to the we will study the properties of cathode rays also, right. So we will study the properties of cathode rays. Yes class, understood? What happened to you? Yes, Kovit Tyagi, Abhishek Yadav, Divyansh, Nikhil, Rudra, Devansh, Priyansh. Nobody is responding. Yes, tell me beta. Understood. Rudra say understood. Okay, good beta. So now some important property we should know, because some important properties of the cathode rays in the experiment by which they have been observed, they have further clarified, they have further confirmed by keeping some object in the path of the cathode rays. So how we can prove these properties, right? As the first properties, they travel in the straight line. How we can prove that the cathode rays travel in a straight line? Because this can be shown by the fact that if you keep an object such as any metal cross is placed in the path of the cathode rays, they cast a shape. They cast a sharp shadow of the object at the back. We can see the shadow at the back, right? If you keep a metal plate on their path, cathode rays path, right, what is going to happen? If an object such as a metal cross is placed in the path of the cathode rays, when cathode rays will generate, what is going to happen? They are going to move in a straight line, but this metal, metal cross is there on the path, right? So obviously they are going to cast a sharp shadow of the object at the back. So this proves, right? So this proves that they travel in the straight line, right? Sometimes the light is coming from one direction, if we stand in the path, what is going to happen? Our shadow can be seen at our back, yes or no? Why? Because we are standing on the path of the light. Likewise, if you keep something like this is a metal cross, for example, if you keep in the past metal cross, if you keep it here, so these are traveling the straight line, and obviously when they are going to pass light can, the obviously they will, this, it is actually opaque object, right? So what is going to happen? They can going to cast a shadow. So we can see the sharp shadow of the object at the back of the discharge tube. Okay. The second thing, when you keep any fan on the, if you keep any fan, metallic light pedal wheel, you can say, or that is made up of mica, suppose, right? It is very light, it should be very light, it should not be very heavy. So this is shown when the fact that if a light pedal wheel that is made up of mica is placed on the path, so what is going to happen? This wheel is going to rotate. When they are going to strike on the wheel is going to rotate. So it proves what? That these cathode rays are made up of material particles. That's why they are able to hit this light pedal wheel, and that's why it is rotating, right? So if we take a light pedal wheel, or it is placed in the path of cathode rays, so for example, when the cathode rays will strike on the blades of the upper half, what is going to happen? Obviously when it is going to strike on the upper half, this is the suppose upper half, right? So what is going to happen? They are going to strike on the upper half, and then it is going to rotate like this. So this point proves that the cathode rays which are generating are made up of material particle. That's why matter have some masses. Because of that only, it means there is something inside, it means they are having some mass. So what is going to happen? It is going to rotate. Metal wheel is going to rotate, right? Then the next property, I hope these two properties everybody understood, that they travel in the straight path. If you keep any metal cross in their path, metallic object, shadow can be seen at the back, because it is an opaque object. Then they are made up of material particle, because if you keep in the path light mica pedal wheel mounted on the axle, it should be mounted on the axle so that it should rotate. Okay, so light mica pedal wheel should be mounted on axle, so that when it is cathode rays strike on the first half, upper half, obviously they are going to rotate, they will start rotating. So it means it is made up of particles, right? Material particles. Then the third very important thing, then they carry negative charge. How we can prove that they carry negative charge? So let's draw something, then we will understand. Let me clear this. Okay, so if you keep something in the path, suppose if you keep let me draw this. Okay, so if you keep one electrical field in the path, right? So what is going to happen? Okay, so if you keep electrical field in the path, so when an electrical field is applied on the cathode rays, they are deflected towards the positive plate, right? Suppose we want to understand that they are carrying, cathode rays are carrying negative charge. That's why so they were moving towards the anode. Anode is a positive. So how we can prove that? How we can prove that? So we can prove with the help of that. If we keep something, if we keep one electrical field, in the path, what is going to happen if you keep electrical field? Suppose this is electrical field. You can see electrical field always have a one positive terminal and negative terminal. So we can keep one. Let's draw this first, you will understand. So this is the one electrical field inside that, right? So if you keep electrical field, when the cathode rays are going to strike, what is going to happen? I will show you how, what kind of changes are going to take place. So let me clear this first. Okay. So when they are going towards this, what is going to happen? They will divert towards positive. They are going to divert toward the positive terminal. Now initially they were going from, this is what, cathode, right? So this is which electrode? Cathode. Initially they were moving towards anode. They were going straight, right? So they were going straight. Now you can see, initially they were going straight, but now you can see after that they cannot go, because we have kept one electrical field on the path, right? So when an electrical field is applied on the cathode rays, they are detected towards the positive plate. It means not detected means they are deflected towards the positive terminal. Understood? So you can see they are moving towards the positive plate of the electrical field. It means they are carrying negatively charged particles. So they are carrying negatively charged particles. Okay. So how we can prove that they carry negative charge? This can be shown when any electrical field is kept, electrical field is applied on the cathode rays inside the discharge tube. So when they will strike, when they will come in the contact to the metallic plate, obviously these rays are going to divert, they deflect towards which plate? Positive plate. They are not going to divert towards the negative, because negative cannot attract. Negative always attract positive. So this fact proves that, right? So when you see the deflection, it means they deflect in the electrical field. When cathode rays deflect in the electrical field, obviously which side they are going to deflect? Positive side. This proves that the cathodes are carrying negative charge. Understood, beta? Class? So one more point I would like to highlight here, right? They also deflect in the magnetic field also, right? So we have proved that the cathode rays carries negative charge. When you keep electrical field, obviously they are going to deflect towards this side. Okay. Now we can see they produces, they produces what? Just wait for a second. Let me shift it. Okay. So they produce green fluorescence on the glass tube, we have seen in the beginning, right? So they produce green fluorescence on the glass walls of the discharge tube, as well as on certain substances as zinc sulfide. If you have a discharge tube has a coating of zinc sulfide, if it is coated with the zinc sulfide, then also you can find, so what is going to happen? You will also get a green, fluorescence. So inside the discharge tube, we have seen the cathode rays were producing green fluorescence on which side? At the back of anode. And this can be also seen that when the cathode rays hit to the some substances, like if the discharge tube has a coating of zinc sulfide, then only then also we can see the green glow. If the whole discharge tube is coated with the, zinc sulfide, then we can see the green glow. Otherwise they are invisible at a pressure of 0.001 mm of mercury, right? In that case, if the whole discharge tube is coated with the zinc sulfide, they can be easily seen. The green fluorescence can be seen, right? The cathode rays produces a heating effect, right? I will show you how. We know that when metals are, if you keep something on the path, right? So obviously when they, are going to, let's use the different one. Okay, so if you keep something in the path, right? If you keep any metallic plate or foil, if you keep any foil in the path, so when they hit the metallic foil, what is going to happen? The temperature of the metallic foil gets increases. It means the cathode rays produces heating effect. Thus, when cathode rays strike a metal foil, it becomes hot, because the metal foil is getting hot. It means it is because of what? Because the cathode rays are going to increase the temperature of the foil. It means they can produce heating effect. So one more property we can prove: if we keep any metallic foil in the path of the cathode rays, the cathode metallic foil gets heated. This proves that they generate the heating effect. Cathode rays produces heating effect. Understood, class? Okay, one more property. They produces X-rays, right? They produces X-rays when they strike against the surface of the hard metal like tungsten, molybdenum, right? So they are going to produce they are going to produce X-ray. If cathode rays are allowed to strike on the against the surface of the hard metal like tungsten, molybdenum, then obviously they are going to produce X-rays. There are three types of rays: X-rays, beta rays, gamma rays. So cathode rays are going to produce X-rays when they strike against the surface of the hard metal like tungsten, molybdenum. Okay, so it means, who has given the name to this particle electron? Obviously J.J. Thomson. When he has confirmed these things, then he has given the name these particle electrons. If I want to simply define electrons, how we can simply define electrons? That the negatively charged material particle constituting the cathode rays are called electrons, right? These are known as electrons. Okay, so from the various studies we can conclude that cathode rays are made of a material particle. We have proved when we have kept a wheel, the light mica pedal wheel in the path, which was mounted on an axle. So it was started rotating when their cathode rays strike on the upper half of the axle wheel. Then second thing, we have also proved that they carry negative charge, because when we have kept the electrical field in their path, so they were deflecting towards the positive plate of the electrical field. This once again proves that they are carrying negative charge. So the negatively charged material particle constituting the cathode rays are called electrons. Understood, class? So I am going to end my class here. I will discuss in the next class discovery of proton, and then we'll study in detail electrons. Understood, class? So thank you very much. I am going to end my class here only.